Hi friends. Okay, this is first lecture for subject mission drawing. This is common for second BTech and second diploma. Second BTech, second year diploma mechanical students. Okay, this course is common for diploma and BTech mechanical students. Okay, this is lecture 1, and in this lecture I will explain about mission drawing. Introduction about mission drawing. Okay, before going to the topic, first of all you have to know the importance of drawing. Importance of drawing I will explain. A technical person can use the graphic language as powerful means of communication with others for conveying ideas on technical matters. Okay, here graphic language, drawing is the example for graphic language. Okay, drawing is the example for graphic language. So a technical person can use the graphic language or drawing as a powerful means of communication with others for conveying the ideas on technical matters. Okay. However, for effective exchange of ideas with others, the engineer must have proficiency in language. Proficiency in language. First one is in language, both written and oral. And second one is symbols. Symbols associated with the basic sciences. And third one is the graphic language. Okay. So engineering drawing is a suitable graphic language from which any trained person can visualize the required object. Okay, as an engineering drawing displays the exact picture of an object. It obviously conveys the same ideas to every trained eye. Okay. Now I will explain some basic types of drawings. The first one is nature drawings. Nature drawings, here, for example, if you want to draw the landscape diagrams, scenery diagrams, that those diagrams are comes under nature drawings. Okay. If you want to draw the maps, that is the India map, world map. If you want to draw that maps, those maps are comes under geographical drawings. If you want to draw the sketches of plants, flowers, okay, like that, those drawings are comes under botanical drawings. Okay. And if you want to draw creatures, animals, okay, that like those drawings are comes under geological drawings. Now if you want to draw the human faces, expressions, human expressions like that, those drawings are comes under portraits drawings. Okay. Now our main subject, that is engineering drawing. For in this engineering drawing, we are using for drawing the projection of engineering sketches. Engineering drawing subdivided into building related drawings. These building related drawings are useful to draw the sketches of buildings and bridges like that. And building related drawings comes under civil department. Okay, civil department and architect departments. Now whereas mission component drawings are comes under mechanical department. In mission component drawings, also called mission drawing. Okay, mission drawing are useful to draw the components, mission component diagrams, assembly diagrams, production drawing diagrams. Okay, now for engineers, mechanical engineers using orthographic projections as well as isometric projections. These are the terms used by mechanical engineers. That is the front view, top view, and side views. Okay, whereas civil engineers uh, plan elevation, side views are used by civil department, civil engineers. Okay, yeah, orthographic projections are 2D, two-dimensional sketches. Okay, now isometric drawings. Uh, Isometric term is related to mechanical engineering, mechanical engineers, whereas perspective projections related to civil engineers. Okay, yeah, the actual object drawing is three-dimensional object. Okay, irrespective of language barriers, the drawings can be effectively used in other countries in addition to the country where they are prepared. Thus, the engineering drawing is the universal language of all engineers. The graphic language had its existence when it became necessary to build new structures and create new missions or the like in addition to representing the existing ones. In the absence of a graphic language, the ideas on technical matters have to be conveyed by speech or writing. Both are unreliable and difficult to understand by the shop floor people for manufacturing. This method involves not only lot of time and labor but also manufacturing errors. Without engineering drawing, it would have been impossible to produce objects such as aircrafts, automobiles, locomotives. Okay, like that, each requiring thousands of different components. Now, I will explain about some topics about mission drawing. It is pertaining to mission parts or mission components. It is presented through a number of orthographic views so that the size and the shape of the component is fully understood. Part drawings and assembly drawings belong to this classification. Okay, an example of a mission drawing is given in figure. Okay, this is the example for assembly drawing. Okay, for this assembly drawing, it consists of four components. Okay, there is one. First one is crank, second one is crank pin, third one is nut, fourth one is washer. Okay, the combination of these four parts. Okay, the combination of these four parts are called assemble. Okay, this is the another example for assembly drawing, but this is a exploded view of machine components. Exploded view is useful to identify the individual components. Okay, now in this slide I will explain some standard drawing sheet sizes. Okay, Now, these are the some preferred drawing sheet sizes. These are first choice. Okay, this is first sheet is A0. Okay, A0 size. The dimensions of A0 sheet is 841 mm by 1189 mm. Okay, so this is the A0 sheet. Okay, here from this from here to here, from here to here the size is 1189. Okay, 1189 mm, and from here to here, from here to here the size, the length is 841. Okay, 841 mm. Okay, so these are the dimensions for A0 sheet, A0 size sheet. Okay, 1189 and 841 mm. Okay, the length is 1189 and width is 841 mm. Okay, now second sheet size is A1, A1 size. So here A1 size, this is A1 size. Okay, from a, this sheet is A1 size. Okay, the dimensions are 594 divided by 841 mm. 594 mm by 841 mm. So here, uh, here A1, the size of A1 equal to half of the size of A0 size. So so two A1 drawing sheets is equal to one A0 sheet size. Okay, so from here to here, the length is half of this length, half of this length, that is 594. Sorry, this is 594. Okay, the length of the length of A1 sheet size equal to half of this A0 size, so 594, and the length from here to here, the length is 841. Okay, so yeah, the width is same. The width of A1 sheet size equal to width of A0 sheet. Okay. Similarly, here A2 drawing sheet. Here A2 drawing sheet. The here the width of this A2 drawing sheet is equal to half of the width of A1 sheet. So here, so this length is half of this length, that is 420. Okay, the length of this A2 sheet equal to 420 mm, and this length is equal to 594. So this value equal to A1 sheet, so 594. Okay, similarly the size of A3 sheet equal to 297 by 420 mm. So here this length is equal to this length, that is 420. This is 420, and this length equal to half of A2 size, that is 594 by 2, that is equal to 297. This length is 297. Okay, now similarly this one is A4 size, A4 size sheet. So the width of A4 sheet equal to width of A3. So this one is 297, and this length is equal to half of A3 size. So that is 420 by 2 equal to 210. This length is 210. Okay, these are the dimensions for standard standard drawing sheet sizes. So these are the first choice drawing sheets, and similarly these are second choice drawing sheet sizes. So A3 by 3, A3 by 4, A4 by 3, A4 by 4, A4 by 5. These are the second choice drawing sheets. Okay. Now coming to the type of lines, indication of lines for drawing. So already we know about these lines. Already we are using in engineering drawing. Same purpose here also. Lines of different types and thicknesses are used for graphical representation of objects. The types of lines and their applications are shown in table. Typical applications of different types of lines are shown in figure. Okay, first type line A, type A line. This is a continuous thick line. Continuous thick line. Okay, so this thick line indicates for outside visible edges, and visible outlines. Okay, this thick line is used for visible outlines and visible edges. Okay, now this is continuous thin line. It may be straight or curved. Okay, this thin continuous line is used for imaginary lines of intersection, and also used for dimension lines, projection lines, ladder lines, hatching lines, outlines of revolved sections, and short center lines. Okay, this continuous thin line is used for B1, B2, B3, B4, B5, B6, B7 purposes. Okay, now type C line is continuous thin and freehand line. Continuous thin and freehand line. So it is, this line is used for uh, indication of limits of partial or interrupted views and sections if the limit is not a chain thin. Okay, now this is a type D line. This is a continuous thin with zigzag. These are called zigzag. Okay, so continuous thin with zigzag line. Okay, this line is used for indication of sectional lines, sectional edges. Now coming to the type E line. This is a continuous, sorry, dashes, discontinuous line with long dashes. Okay, this dashed thick line is used for hidden outlines. It is used for indication of hidden outlines. Now this is a long line, short line. Long line, short line. This dashed chain thin line is used for indication of center lines and lines of symmetry and trajectories. Okay, Now this Z type Z type dashed line is used for indication of cutting planes. Okay, this type of line is used for indication of cutting planes. Now this type J line, that is thick, thick, long line, short line, long line, short line, line, thick chain line. Okay, this line is useful for indicating the lines of surfaces to which a special requirement applies. Okay, now this thin chain double dash, that is a long line, short line, short line, long line, short line, short line, long line. This double dashed thick chain line is used for indication of outlines of adjacent parts, as well as alternative and extreme positions of movable parts and centroidal lines. Okay, these are the different types of lines used in our mission drawing subject. Now coming to the another one, that is hatching. Hatching, here I will explain about the importance of hatching. Okay, these lines are called hatching lines. Okay, hatching is generally used to show areas of sections. Okay, hatching lines is used for showing the sectional views. The simplest form of hatching is generally adequate for the purpose and may be continuous thin lines at a convenient angle, preferably 45 degrees to the principal outlines or lines of symmetry of the sections. These are the preferred hatching angles. Now this is the example for hatching. Okay, here 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 I am using 45 degrees angle for drawing the hatching lines. Here the angle between principal line and this hatching line is 45 degrees. This outside boundary line is called prefer outside boundary line is called visible edges, and also you have to treat it as principal lines. Okay, now the angle between principal lines and hatching line is 45 degrees. It may right side hatching or left side hatching. It depends upon diagram. Okay, yeah, this is the example for hatching of adjacent components. Okay, separate areas of a section of the same component shall be hatched in an identical manner. The hatching of adjacent components shall be carried out with the different hatching. Okay, so here this one is one part and this one is another part. Okay, for this part I am drawing hatching in left side hatching. For outside part I am drawing right side hatching. Okay, for separating the components I am using different hatchings. Okay, this is also another example. This one is one component and this one is another component, so you have to give a separate hatching for separate component. Now this is also another example for hatching of adjacent components. Here this is this bottom part I treated as a part 1 or component 1, and this middle section I treated as part 2, and this outside part I treated as a part 3. Okay, here totally three components are there. So for showing differently. Okay, uh, I am drawing left side hatching for bottom section, and I am drawing the right side hatching for top section, and for middle section I am drawing left side hatching but different dis- different style. The distance between hatching lines are smaller than the bottom and top sections. Okay. uh, Now I am showing examples for mission drawing. These are the examples for mission drawing problems. In question paper, it consists two parts, that is part A and part B. Part A having part drawings and part B having assembly drawings. So these are the examples for part drawings. These are the components, engineering components. These are the conventional representation of mission components. Okay. Now this is the conventional representation of thread profiles. Conventional representation of thread profiles. These are the orthographic views of a bolt and nuts. This is a hexagonal nut. Okay, this is the orthographic view of a nut, and this is the orthographic view of a square nut. This is the bolt, hexagonal bolt. Okay, these are the different types of bolts and nuts. This is the chapter 2, and this one is different types of keys. Different types of keys used in mechanical mission components. Okay, this is sheet number 3. Now this is the another topic, that is quarter joints. Okay, these are also used in mechanical mission components. These quarter joints are used to join the two or more shafts. Okay, these are the quarter joints. Now another topic is very important. This one is shaft coupling. Shaft couplings. These are also used to connect or join two or more shafts. Okay, these are the different types of shaft couplings. This one also part A. Now last topic in part A is rivets and riveted joints. Okay, these are very important in exam point of view. These are the different types of rivets. Okay, rivets and riveted joints, lap joints, butt joints. Okay, up to this topic, up to this topic, these are in part A. Now coming to the part B, that is assembly drawing. Assembly drawing consists of part drawings as well as assembled answer, assembled view. So this is the question for assembly drawing. This is the answer for assembly drawing. Okay. In question, it consists of individual parts, whereas in answer we have to draw the assembled view of a component. The assembled view means you have to draw the front view and top view and side view of a final assembled view. This is the example for stuffing box. Now this is the example for screw jack. Okay. This is the example for eccentric. Okay. And this one is example for lathe tailstock. Okay, this is the lathe tailstock assembled view. This is the example of single tool post, and this one is example for petrol engine connecting rod. Okay, this is a connecting rod. and this one is a steam engine connecting rod, steam engine crosshead, and this one is a milling mission tailstock. Okay, this is the example for milling mission tailstock, and this is the example for footstep bearing. Okay, this is the example for footstep bearing. This is the example for plumber block bearing, and this one is the example for blow off cock. This is the example for square tool post. Now this is the example for non-return wall. Now this is the example for knuckle joint. It is very important. Now this is the final example of Oldham coupling and universal coupling. Okay, these all are assembled drawings. Okay, okay friends. In tomorrow class, I will explain one by one. Okay, okay. Thank you.